meetings naye ano tannamutinga gwe musajja mukulu ow'ekiro president kwa the earphones
Yalinda kukasimbo ka muting nga
teekamu earphones ebyo mutinga sooka obireke
soko kanayo kati ndaba mukono gwo
ne mulungi mu bino ne bw'oteekako oba tebigenda kukkiriza
so gojja community eyo unmute ours, then I mute this one here who doesn't know how to mute. Muted him then muting. Kati Django unmuting one. OGGM unmute. So I'm putting one there. Okay. I think you can present now. No, it is inverted. So you are live. You can hear you.
I was also sharing a screen. Yes, good evening everyone. I hope I'm loud and clear. And I want to introduce myself because I know everyone knows me here. And I'd like to welcome you to our sessions. Thanks for being serious and supporting our progress. So today we are going to look at programming, which is the advanced programming in Java. And I know most of you have been worried about what the lecturer said, that you need to have some knowledge of C++ to continue with Java. And according to the criteria that he has been using while teaching, I've been seeing him, he has been comparing C++ then with Java. And I wouldn't like to say he does it in a wrong way, but you have to look at a concept that some people didn't see C++. And besides, Java is a standalone programming language. It works as an independent language, meaning without the knowledge of C++, if you are well taught, you have good resources, a competent lecturer, you can still get the programming. You can still understand what programming really is. So, as we wait for other people to join, I'm going to give you a brief overview of what you should focus on in the prospect of preparing for this incoming test. I would like to first take you through the things that you need to first focus on as you prepare for this test that is incoming. So we remember that we share the lecturer shared some notes. That is lecture 1, lecture 2, those ones that are more of theory, where we have the testing, verification, software design, those processes. So as you focus so much on the coding, please take time and look into it as well. Take time and look into that coding as well, so into that theory part of it. Because most of the questions, of course, as you know, a test is not so much broad, doesn't cover very broad details. So that means you will need to have some theoretical background to pass the test as well. And yet, as of today, we are going to focus so much on understanding. We're going to focus so much on understanding the coding. We are not going to talk too much about the theory. We're going to focus so much on understanding and understanding the practical bit of it. So we are going to start from coding, the basic syntax, then what you should know, the rules, the naming conventions, and then we shall continue proceeding to further areas. So as of now, I want us to, I don't know if you are seeing the screen I'm sharing, but I'm not going to, okay, behind, what you see behind me is the IDE, just CP edit. And I'm sure most of you, I gave you this IDE that you are seeing in the background, this one, the JCCP edit. This JCCP edit is the one we are going to use throughout for most of our sessions as beginners. When we come to programming or to developing GUIs, call them the graphical user interfaces, that's when we shall switch to Eclipse. So as of now, if you can bear with me, I would like those without JCP who are using Eclipse that we are going to use just CP edit. If you feel like you are okay with Eclipse, well and good. But those with just CP edit, you know the procedures. Whenever I want to create a new file, you just come to File, New File, then you choose the type of the file. Then after, of course, we shall choose Java because we are working with Java. And then, excuse me, let me first admit this person. Someone wants to join this call. No, it's okay. Share that with that person with the link if he's part of the what? Oh, sorry. Okay. We were saying that based on this software that we are working with, that is the JCP Edit, you come to File, excuse me, New File, choose the file type, and as of now we are using Java file. Then after choosing Java file, you give it a name. Probably you can choose any name based on what you want to start with, and you can say fdemo as your name. But remember that when you create the name, whether in Eclipse or in JCP Edit, whether Eclipse or JCP Edit, the moment you give a file name, that will be used as your class name. That will be used as your class name. Meaning, yes, you'll excuse us for a while. I think my screen had disappeared.
You continue. Okay.
So, like you say new file, you choose the file type. I don't know if people are seeing any changes on my screen, because I may be working when the screen is consistent. Is there any change? Like, are you seeing what I'm explaining, or you just seeing a stationary screen? So you give it a name. Probably you can say fdemo, and we are saying you give it a name that represents. A minute, please. Okay, so you excuse us with that. So I was like, you have created a file and you've called it fdemo. Then after you say create, you tap on the create button like that, and they are telling me that already the file the name already exists, which is okay. I'm just going to adjust a little bit and say demo with capital D. Then I say create. Still it exists. Select a file. Yeah, we said you select a file. That's file type. We are working on a Java file, and you say create. You see that it automatically creates for you the basic syntax. And when I say the basic syntax, someone will tell you define a syntax. Syntax means just a format. The format or a structure, a legal structure of a certain programming language. Like for this case, our structure is supposed to be like the one you see on the screen. I don't know if it is clear. The one you see on the screen. You always start with public class demo, public class, public, the one you see in blue color, this one, that one. It's just an access modifier, so don't focus on it so much. We shall understand access modifiers in a short time to come. but it is a keyword, so meaning it will not change. Whenever you want to use it, it will be like that. Then the class is also a keyword, the one you see in red, that one which I've highlighted to become blue. That one is also supposed to be there. It will never change. It will never change. Then fdemo is our class name, the class name that we have just chosen. Okay, yes, thank you. We were continuing by saying that as of now, focusing on what we see here, this is the class name, right? And this one changes based on which name you want to create. And you have to make sure the name you have chosen here as your class name matches with the name of the file as you see here. Are you seeing fdemo here as our file name is the same name as the class name? If you don't do that, the program won't run. And I'm saying, why am I saying that? Sometimes you'll find in a program you have many classes, but again you have to know that the class that has the main method should have the name of the file. In other words, this is our main method, this one here. The role of that statement creates the main method. Here you can see public is also just an access modifier, and I will explain a little bit about it. Static is also a keyword, void is a keyword, and even the word main will not change because the main is the name of our main method. It is under this main method that the execution or running of the program starts. Meaning every program you write has to be a class, at least it has to be with one class that has the main method, right? Then inside here we can see string, and that string means what? String is like data type, and it is also supposed to be there inside. It can never change, and you have to mind that it is capital S, then the other letters are small. Then arguments, args, this one is read as arguments. That one is also supposed to be like that. Then the square brackets can come at in front of after edges, args, or before args. Args means arguments. We shall understand what arguments are in short time to come. So like that, you open the main method here at line 4 and close it at line 5. But still, even the class, you see that we opened it at line 2 and we closed it at line 7. And for this case, we are going to be excusing me that I will not explain so much on what a class is, what is an method, but we shall further get to understand them when a short time to come. Because as of now, I'm focusing so much into the coding, but when we come at that specific point where we're going to focus on understanding each and every concept, like as we code, you shall understand better. So right now I'm sharing my screen. I hope you can see. Inside there, I'm now sharing the Google web page, and I'm saying we have whenever I discuss, I use so much this link that is called Java Overview. You just put in Java Overview, then you search, you see my outcome, then the first link, that is the one that is tutorials point link. That one is the one I use when I'm discussing. And as of now, I'm assuming all these subtopics we are going to skip and move to Java Basic syntax. Java Basic syntax, the one that we have been trying to look at here in GCP Edit. This one that runs from line 1 to line 7. So just like we were seeing that syntax there, we are going to start from there to start understanding the programming. So from Java Basic syntax. We have a lot that we are going to look at, but we are going to avoid so much focusing on the theory, because the practical explains the theory. So if you have the practical, the theory will be easy. However much, as a matter of emphasis, I'm going to first explain the theory that concerns object-oriented programming concepts. Those ones are very key, that I cannot do any programming unless I make people first understand those concepts, because I'm going to be using them so much, so often. And for that reason, I'm going to dive into what we call the object-oriented programming concepts. And they are around 5. That is the object, class, methods, and the variables, right? So object-oriented programming means that, why do we say object-oriented programming? It's because this is the programming that deals with objects, and we're going to understand what objects really are. And we are saying object-oriented programming as a programming language, it has what we call object-oriented programming concepts. Hope people can see the screen I'm sharing right now. Is it clear? Like, are the words clear? Those ones. So we are saying we have around 6 to 5 concepts that we have to first understand in Java, then we can continue with the coding. And these ones are very vital, that they are highly examinable. They have two marks at least for each if you can define and give an example. They can even carry 3, that's if someone asks for the example. So looking at the object, what's an object? First of all, when you look around you, you see a lot of things. You have a computer, you have a phone, you have you yourself, you are an object. So meaning Java looks at everything in the universe as an object. So we have to find a way, if we want to develop a system, we need to change to insert, or in our system we need to look at the different entities we see in the world as objects, and we see how we can incorporate them to fit into our program, into a software. We are converting the hardware we see into the software. Then that's achieved by using objects. Now we come to define what is an object. An object is just a real world entity. Because when I was talking about an object, I told you to look around yourself. Whatever you see is an object, meaning any entity you see, any real world entity you see is an object. So an object is just a real world entity. Full stop. So if an object is a real world entity, that means anything you see is an object. And what you see, the only way you can explain to your friend what you see, or you can define to your friend what you see, is using certain properties. Meaning, if you want to tell me that the phone is brown, you have used the property color, right? Or an attribute color. If you want to tell me that you are tall, you have used an attribute of height. Meaning, every object, to define it or to explain it, you have to use properties. So every object has properties that define it, that make it to exist. And still every object does something. It performs some tasks. As a human, when you wake up as a man or as a human being, you walk, you talk, you move, you laugh, you read, you write, you perform some tasks in a day. And those ones we shall refer to as methods in our programming, but we shall come to that. So what you do as a human, the tasks you do are the ones we are going to call methods. So as an object, you see here, we are saying that an object has properties and has tasks performed. And the definition is just a 3-word definition. Real world entity, that's the definition. Even if they have attached the 2 marks, still that definition is enough to stand. Yeah, yes? So you give that definition, you may go on to even give some examples of anything you see. Or you can say an object is an instance of class. We shall understand that definition in a short time to come. So examples of objects, we have the humans. And the humans have properties. Which properties? We have a name. At least every human has a name, has a color, has a height. And every human has some tasks that he can perform. We do work, we run, we write, we read. So those are the methods. And then after we have understood now what an object is, we move to the next concept, that is class. So a class, in a brief understanding, if you have to understand it briefly, it is just a category, right? It's a category. However, this category shapes what other objects under that class will look like. So meaning a class is just a class is like a blueprint. Look at a building. We have very many buildings, but each and every building has its own characteristics and or properties and attributes. But every building has a specific plan that helps it to exist. Without that plan, the building will not exist. That means a class is a blueprint or a plan that an object follows to exist. For example, if we look at students as a class, we have very many students. We have students like Derek, Mutebi, Collins. All these are students, but they have what specifically differentiates them from each other. But they fall under the category of students. That as what makes you a student, you read, you write, maybe you play, maybe you pay, you have a roll number, maybe you have a name, maybe you have date of joining the university, right? So meaning you can have a class students, and under these class students you have various different students that are specific to themselves, and then those are what we call the objects under a class, right? So you have a student class, and we are saying this class has properties, or call them variables, like name, roll number, and then date of joining the university. Then each and every class has its own tasks, or every object under this class performs tasks, which we have called methods. In programming, we call them methods, like read, write, and play. So hope we have understood what a class is. And we are saying a class is just a real world, and we are just saying that a class is a blueprint that an object follows to exist. Blueprint that an object follows what? To exist. That's why we said that still an object is an instance of class. We usually hear lecturers saying for instance. For instance, meaning he's trying to tell you for example, right? For example. Meaning an object is an example of a class. An object is an example of a class. Sorry, I may be taking you too fast, but if you feel like you want to ask anything, feel free to ask, to unmute and ask. Yes, you can unmute and ask. Probably I may not be able to see the messages that you may send under the chat C blob, or the chat C. You may send a chat that is a text, and I may not get time to see it, or you may raise a hand and I don't get to see it. But if you feel like you want to ask anything, I beg you what you unmute and ask. And if anyone is not so busy, I beg you can help me, and you notify Mr. Henry Dema that our session is ongoing. He may not be informed, so that he can join. Thank you. Let's continue. We are moving to the next concept, that's abstraction. Abstraction, right? We have understood what a class is, and we have understood what an object is. Abstraction comes from the word abstract, in other words, to hide, right? So as abstraction sounds, abstraction just means that you hide something. So abstraction is the hiding, is the showing of only essential parts and hiding the implementation details of the entire program. What do we mean here? That as you who is using WhatsApp or who is using Google Meet right now, you don't know which codes were written there exactly to what? To enable you to use it. For you are just continuously using the what? The Google Meet. But when they ask you which codes were written for you to achieve this, like for you to be able to use the Google Meet, which codes were written, and like the back end, you don't know. And you are not interested even in knowing, because your point of interest is in seeing, can I use Google Meet? Can I join the meeting? If yes, that's all you want to focus on. You don't need to know which codes were written in the background for you to achieve that. So meaning, here the programmer will hide the essential part, will show only the essential parts. In other words, we will only show you the user interface, and you'll be able to use the software, but you don't know which codes were written. That is what we call the implementation details. You don't know how the software was implemented, right? You don't know how the software was implemented. The only thing you see is how you can use the software. So that is what we call abstraction. We only show you the essential parts of the entire program, and then we hide the implementation details. So that's the abstraction. So abstraction, the definition is that it is the process of showing only essential parts of the program and hiding the implementation details, right? For example, when you download an application from Google Chrome or Google Play Store, it comes with an extension .apk or .exe for a computer, but you don't know. All you do is just to install and start using. You don't know which codes were written to achieve that one, to come up with that software. So that's what we call abstraction. Then the next concept that we are going to look at is the encapsulation, hoping that we have understood abstraction. So encapsulation also comes from the word encapsulate. Just like you will have a tablet, which is a capsule. These tablets that you will know, the capsules, I think people know capsules. I don't need to explain so much on what capsules are. A capsule tablet. Let me show you how it looks like. That I can explain to you this concept. You don't need to cram the things. You just have to relate the English with that. You just have to relate the English with what you want to explain. You see this tablet here, this one, it is a capsule. Because in it, they got all the different medications that are going to heal you, and they put them in one capsule, right? So what they did is encapsulating. They encapsulated all the medicine in that one capsule. And for you, when you take it, you have already healed. That's how you come to heal. So, meaning encapsulating also means the same thing here. We bind, or we collect different variables and methods, and we bind them under a single entity. So, what does that mean? Encapsulation is the binding of variables and methods under a single entity. For example, a class, we said we can have a class student, like you see here, class student, and under this class we have very many variables and methods like name, roll number, date of joining the university, read, write, and then play. That all these variables and methods are encapsulated or are binded under a single entity, that is a class student. So binding variables and methods under a single entity is what we have called encapsulation. That we encapsulate different variables and methods under a single entity. Hope that one is also clear. So we move to the next concept, that is inheritance. And inheritance also comes from the word inherit. To inherit, we know what that means. You can inherit your father's property, or you can inherit your mother's property. And so inheritance comes from the word inherit. In other words, for those who know Luganda, that's what we call okusikira. Osika, no fuko musika. The hair and then the heiress. So for someone who has kusikira, who has inherited the land of a father, maybe that one is what we call the child, right? You are the child who is going to inherit your parents' property. So inheriting also here means that we are acquiring properties of one class to another class. So inheritance is the acquiring of properties of one class to another class. In other words, we get properties of one class and we acquire them to another class, or we give them to another class. Okay, so then the other thing you need to know is that in the concept of inheritance, we have in the concept of inheritance we have what we call if you are to inherit, that means there should be a father, your father who is going to whose property you are going to inherit, whom we have called the parent. But still, there should be you, the child, who is going to inherit. So for that reason, like we have said that here we are looking at classes inheriting properties of another class. That means we have to have a child class and a parent class, right? A child class and a parent class. Meaning, we are going to have a class which is going to give properties to the other younger class, which we have called the child class. And then we shall say that the child class is going to inherit properties of the parent class. Then the other term that can be used interchangeably is that if you're a parent, you can still be called a super class. If you're a parent class, you can still be called a super class, as you see here. We have the super class, which can also be called the parent class and can also be called the basic class, right? And still, if you are a subclass, you can also be, so you're a child class, you can also be called a subclass or a derived class. But this is how it works. That if you have chosen to call your parent class superclass, then that means the child will be subclass. Superclass, then the child will be subclass. Parent class, the child will be child class. If you say you are looking at a parent class as a base class, That means the child will be a derived class, a class that is derived from the base class. Then the subclass, the parent will be a super class. So if they tell you to define any of these three, the words won't change. The words won't change. So we shall say, what is the parent class? The parent class is the class that is going to acquire, or that is going to give properties to the child class. Then the child class, the one that acquires properties from the parent class. And we need to know that inheritance comes in three types. That is single inheritance, multi-level inheritance, and hierarchical inheritance. And as of now, just know that we have those three types, and we shall come to understand them further in a short time to come. So as of now, just get to know that we have those three. If there is anything, I'll first talk about them briefly, but as of now, first get them. There are three types. Then we move to the next concept, that's polymorphism. Polymorphism. Usually we hear the lecturer says polymorphism, but the word is polymorphism. So never should you reach in the paper and then you write with O here. Here we don't have O, it is I. So it is polymorphism. For something to be polymorphic, what does that mean? Poly means many, right? Then morphism means forms, right? Poly means many, then morphism means forms. So simple. Java is English. So if poly means many, then if morphism means forms, that means polymorphism will be performing this, something existing in many different forms. So the Java way of defining this polymorphism concept, you will say polymorphism is performing the process of performing the same task in different ways. So polymorphism will be performing the same task in different ways. You can also, or you can say, performing the same method in different ways. What does that mean? That if we look at a method of maybe adding, right? That if you are adding two numbers and use the method called add, yes, you can choose to write a method add with the parameters. What do I mean when I say parameters? Parameters, I mean like when we are writing a method, we write a method name, then we open these brackets and close them as you are seeing here. Then inside these brackets, if you have anything, that is what we call parameters. If you don't have anything, then that means it is none. It's a method without parameters. So whatever we have inside here is what we call parameters. So someone can write the same method add without parameters, then another person writes the same method add but with the parameters. So these are the same method, same name, same method name, but different number of parameters. So this is what we have called polymorphism. You are doing the same thing, you are adding numbers, but here you are passing parameters, and here you are passing parameters, and here you are not passing parameters. So there we see that you are trying to perform the same task but in different ways, right? Then the other example that can explain it further is the draw polygon method. If you have a method called the draw polygon, you can have the same method, but this time it is drawing a polygon which is a square, or a polygon which is a rectangle, or a triangle. Same method, but it is doing different things. Meaning we are performing the same method to achieve different things. And you need to know that polymorphism comes in two types also. Compile time and then run time. Compile time polymorphism and run time polymorphism. Then we say that compile time polymorphism, that is performing the same task in different ways at the time of compiling the program. Simple definition. The same definition, but only that you specify and say, but this happens at the time of compiling the program. That's why we call it compile time. Compile time. I'm assuming people know the difference between compiling a program and running a program. Because we see that compiling a program, this is just a process of changing the program from a human language into a machine language. You are just changing these words, because these words we have written in Java, those ones, that is English, and the computer doesn't understand that English you have written there. Those letters, the computer only understands zeros and ones. So they have to be changed to zeros and ones, and that process is what we have called compiling. Then, if you have understood compiling, that means you now know when we say compile time polymorphism. Then runtime polymorphism, running a program. It comes from the process of running a program. So here I have written the program, right? So if I press here, you see they're telling me compile file. So when I tap there, you see here below they are telling me that compilation successful, but nothing has been viewed, meaning it has compiled but it has not run. So if I want to run the program, I will tap here. You see they are telling me compile and run. When I compile and run, you see something comes up. So there I'm running the program. The program has run and I'm seeing some output or some results. However much now it's doing nothing. So that's what we call running a program. So you can you first compile. Compile happens first. After you have compiled, then the program runs to bring output. That process I'm not explaining it again. You can just go in our theory and you look at it in your theory and you understand it. As of now, we are looking at polymorphism, and we are saying it has two types: compile time and run time. And then we are going to say that compile time polymorphism happens at the time of compiling the program. Then runtime polymorphism happens at the time of running the program. Then what you see here, they are trying to tell you that compile time polymorphism, an example of compile time polymorphism is method overloading. Then runtime polymorphism, method overloading. So method overriding. We shall understand these two, so don't worry. We shall come to understand these two, the differences, how do they happen. So we have understood what polymorphism is, and we have understood what object-oriented programming concepts are. They are just 6, and I beg you remember all of them to make sure I don't lose out on the 12 marks or 10 marks, which I am sure they will be there. Either it will come in a test or in the exam. Any of those two, but it has to be there. So let's move to the next concept. The concept of keywords. All of us know what keywords are, so I'm not going to look at that. Maybe I can give you a brief definition that keywords, these are words that have a specific meaning in Java as a language, so we cannot use them anyhow. So that is the keywords, meaning these words are specific. You can't just use them anyhow. And those are some of them. What you see there are some of them. You don't need to cram them. As we do the coding, you have to remember most of them. So those are the different words. They are keywords. You cannot use them anyhow. And there are many, but if you can remember, those are the ones that we use so commonly, so often. And you have to know that all data types are keywords. So I'm just taking you through briefly the theory, but we didn't come to read to focus on theory. But what I'm doing is called the panel beating. I'm taking you through the simple theory, then we can start on the coding. So naming conventions are just like rules that we follow when we are choosing names for what? Names for our classes, methods, variables, and objects. So you see that the name should not match with any of those keywords. That's the rule number 1. Other rules, there are even other rules, but as of now, you'll go and look at this link that I shared with you. I don't know if I shared it. If I didn't share it, it is okay. I'm going to share it in our platform. If you want to review it, if you want to look at anything that I have not explained in great detail, you can just go and look at that link that I've shared on our platform, and you understand. For example, I'm not going to focus on explaining all the naming conventions, but you can just go and look at them, read through them. They have some 4 marks there. And besides, apart from the 4 marks when they ask you to state them, if you don't know them, you won't pass. You don't get any mark, because that means you will break them. You end up using a keyword as a class name, which is not allowed. If you don't know these naming conventions, it will be hard for you to pass. Meaning you will have branch name, yet you know that you don't have to be with the space. You find someone spacing these 2 words. You see how important it is to know the naming conventions? That we should not have any space between the words, or we should not use any special character like a symbol. So if I find someone using a question mark, or starting a name with a number or an alphabet, you'll be breaking the rules and you get a 0. I'm assuming if the lecturer finds out, like many people have passed, and you make a blunder on one line of a program, you will be the sacrificial lamb. You will be the collateral damage. he has the right to say you are wrong, the whole program is wrong. Because of course we know that if the program has one error, it is entirely wrong. So he has the right to mark other lines or to cancel from where you have made the error, and you get 0. Meaning if you have written a program that spans up to 10 marks, because we saw in C++, an exam could come and only one number, you will have to write a code that gives you 12 marks. Meaning if you lose out on 12 marks, that's so much. So go back, read through the naming conventions. However much as we do the programming, I'll try to panel bit and talk about them. So as of now, I'm skipping them. Same thing, data types. Data types are very important. They can also take you 6 marks or even 12. If someone tells you, explain the different data types we have in Java, showing where they can be used or when we can use them. Those are 6 marks or even 12. So, and I'm not going to look at them, but I'm going to advise you to go please and look at that link that I've told you. You see the part where we have data types and you read through them. See, when do we use a byte? When do we use a character? When do we use a short? When do we use a long or a float? Right? Yeah, as of now, just look at the screen I've shared and know that we have we have a lot of them, but you need to know that all data types are key words, and all data types are written in smaller letters, except the string, array, and the class. Okay, so except the string and array data type. But we shall understand them as we continue with the coding. So as of now, I'm just going past them. Now we look at the input and output streams, like how would we input data into this program and how do we output. Those ones we are going to understand mostly in the coding part, so I'm skipping them. Command line arrangements, don't worry about them. Okay, different types of variables. Hey, that one will require that you first understand what a variable is. A variable, we said last time that a variable is just like a placeholder. For example, we see when you look at programming, so when you look at your memory, if we are to look at a computer's memory, right? A computer's memory is a chunk. What do I mean by saying it's a chunk? It's like a box. You have a box. Let me first try to show you something here. If I have a box here, let's assume a memory. You have a memory which maybe is an SSD. I'm not going to talk about hard disks because now we are in an era that where we don't use hard disks. And hard disks are no longer something that you can prioritize when working. So, are you seeing that text box? That text box is now our memory, and this memory is divided into different partitions. It is divided into different partitions. Like that. So these partitions, maybe they are named for the computer names it according to what we call memory addresses. Maybe memory address is 0101, so 0121. Memory address is sorry, it's a mistake. Computer doesn't understand it too. Maybe 011, 110. 111, 110, like that. If you want to use a memory location in this, you need to tell the computer to reserve it for you. So that is just a memory address, but you have to first tell the computer to reserve that memory for you. For example, you want to store something down here. Maybe this is the address of the memory location. Then this is the memory location. Maybe the memory location is this one. You see that it doesn't have any name because the computer doesn't name memory locations. It just holds them as memory addresses. So for you as a human, you won't be knowing that now I want to store at memory address 011 because you are not working as a computer. So you have to tell the computer that I want you to reserve for me a memory location that is going to be able to store, or a memory address that is going to be able to store maybe a number. That is if you are working with numbers, and please name it so and so. You give it a name, and by doing so, you are creating a variable because it is just a memory location. Its value can change. What you have stored there can change at any time. That's why we call it a variable, from the word varying. Its value can change at any one time. So for you, by you saying int a, you are trying to create a variable a. A with the named that is named a. So you have told the computer that please reserve for me memory, some memory, and please name it a, and make sure it can store an integer. So that's why you will say int a. Here you have created you are telling the computer to reserve for you some memory, and let that memory be able to store an integer. Why is this all important? Because we know that different data types occupy different space on memory. So if you tell the computer that reserve for me some memory and you don't specify the data type, you won't be wasting time, because for it will not know, should I reserve some memory that is capable to store a value, an integer, or even a string, or even a float, like a number with decimal points. Because we have said an integer will occupy different space on memory. A float will also occupy different space on memory. And so is a string. So the importance of specifying data type will help the computer to know which size of space or which size of memory should I reserve for this person. Then what is the importance of giving it a name? Because you as a human, you want to be able to remember that you stored it on 001 or 110. But you can remember that I stored it in A, because A now will be the name of the location. And when you are in C++, in C, not in C++, in C, we have what we call pointers. Those are concepts that point where you can access the memory location, but by just pointing at the what? Pointing at the address. When you point at the address, the computer will check. And under that address, is there any variable? Yes, then it accesses the value in the variable. But as of now, okay, for Java and C++, for Java we don't use pointers. What we do, we just access directly using variables. So a variable is just a named memory location capable of storing value or data. So after we have understood what a variable is, variables have different types. We have local variables, instance variables, and static variables. And these ones, they can also ask you to define them. And even if they have not asked you to define them, if you don't know them, when you come to the coding, you will lose out, because you will not know what is so special about a local variable and an instance variable and a static variable. But what you need to know is that knowing the type of variable you are working with is very important, that it can help you to know beyond which instant or beyond which part of the program can this variable be accessed. In other words, the type of the variable specifies the scope or the lifetime of a variable type or a variable being talked about. So when you look at a local variable is declared within a method and is can be directly accessed. Let's look at our program, this one. See, here we have a method which we have called the main method. If I go on to say int a, what I've done is that I've declared a variable a, which is a local variable. It is local in which way? That it is declared within a method main. It's declared within the body of the main method. This is the body of the main method. It starts at line 4 and ends at line 6. Yes, we are continuing. Okay, someone says come again on the definition of a variable. A variable, we have said, it's a named memory location capable of storing data. That's all. It's just a named memory location capable of storing data. And then we are saying we have 3 types of variables. Yes, we have 3 types of variables. And if you are not sure, if you have not heard the definition very well, the other link I've shared has the definition clearly. They have said it. Doesn't change so much. However much mine might be a little bit brief, and because I want to give brief definitions, because it becomes easier for us to remember. As engineers, We are not good at cramming lengthy things. We want more of calculations and we move on. But that definition is easy to remember. So we are looking at variables, and we are saying we have different types of variables. That is local variable, instance variable, and static variable. And we are saying, what is a local variable? A local variable is a variable declared within a method. Full stop. It's a variable declared within a method and can be accessed directly. That one we shall understand. Then the other type of variable is the instance variable. We are going to understand further, don't worry. So the instance variable is the variable declared inside the class but outside the method. That one is very important. It's declared inside the class but outside the method. And it is also accessed through an object. We can only access it via using an object. We shall understand what objects are. Okay, we understood what objects are, but we shall understand how they look like. Then what is a static variable? A static variable, this is a variable declared using a static keyword, and it can also be accessed directly. In other words, the static variable is the same as an instance variable, only that for it, when you are declaring it, you have to use the static keyword. That's the only difference. And for it can be accessed directly. You don't need an object to access it. You can access it using the class maybe, or you can access it directly. We are going to understand what do we mean when we say accessing it directly. So those are the brief definitions you see there on the screen. We are saying it's declared within a method for a local variable. Then for an instance variable, declared inside a class but outside the method. Then the static variable is also declared within a class but outside the method, but using a static keyword. We shall understand when do we use a static keyword and how is it important. Because we don't only use it on variables, we also use it on methods. So let's move to brief understanding. So examples of variable declarations. That one is not important. We know how to declare a variable. That one we know. If you don't know, look at this one. For those who are not yet clear on how do we declare variables, see this first line. We are declaring variables, but we are declaring variables on the same line. Multiple variable declaration. We are declaring variables on the same line. And that one is only allowed if you are declaring variables of the same data type. Hey, don't be like you are declaring a string and an integer and you are doing it on the same line. It cannot happen. When you are declaring very many variables, make sure you are declaring on the same line, like using the same statement. That's what I'm trying to mean. Like if you want to use one statement to declare multiple variables, please make sure those variables have the same data type, right? That one is clear. Then the other way of doing it is that you can declare and initialize at the same time. You declare and initialize on the same line or on the same statement. Yes. Okay. Someone is what?
Is waiting in the lobby.
Okay, sorry. Okay, Mr. Simon, you're welcome. We haven't gone far. I'm sure you'll catch up very quickly. And let's continue. We found us when we are trying to understand variables, different types of variables and how they work. And we are saying, we are now briefly looking at how do we declare a variable, and what is called, when they tell you to define what is variable declaration. Variable declaration is very simple. It's the process of creating a variable, full stop. You are just creating a variable. You are just telling the the computer, that I want you to reserve for me three memory locations. For example, for line 1, here you are just declaring 3 variables. You are telling the computer that please reserve for me 3 memory addresses or memory locations, A, B, and C. Name them A, B, and C, and let them be able to store an integer value. So that's what we call declaring. And then initialization, here, you see, these ones, just don't focus on these things. These ones are in the gray line, so in the gray color. They just show that they are trying to explain what is on the right hand so on the left hand side. So they're just comments, explaining what you see the other side. So focus on these ones which are colored. So I'm saying line 2 tries to show you that what we call initialization. So the process of when they try to define initialization is just storing value in the variable. You are trying to store a specific value in the variable that you created or in the memory location that you created. And that is shown on line 2. On line 2 we are filling 10 and 10 in different the variable b and a. Then this one you see byte is also data type. It's also data type. So it's also just initializing a byte type variable b. So let's not waste so much time on that. We have seen 3 types of variables: local variable, instance variable, and static variable. We have seen how they work like, and then now here we are looking at an example. See this example? Here you can see when they tell you someone can write for you this code the way it looks here, and tells you to tell us which type of variable is age. Which type of variable is age? Some of you will be saying it's an integer variable. No. Integer is just a data type. It doesn't mean that the variable is an integer data type. So an integer type. Integer is a data type, but it's not a type of a variable. Unless if they had asked you what type of data is the age, that's when you say integer. But if they ask you which type of variable is age, there you will say it's a local variable. Why? You see this written in the class in the variable. So in the method, the pup age or pupil age. This is the method. Why is it a method? Because we said for a method, you write its name and you open these brackets. These ones you see here. That's what makes it a method. And then the other thing is that it has a data type. So data type that now is what? Is a void. And the other thing is that this is just an access modifier, meaning that this method is public. Public means that whatever I am writing is accessible throughout the entire program. It's accessible, like it is open to other parts of the program. If there is any other class, it can access that method, right? Like a child class. So this pup age is the method, and we see that it is someone opened it and closed it. Opened it here and closed it here. I think let me just copy this method and this program and I paste it in our compiler and we understand it better. See online. Okay, it is bringing an error because the name doesn't match the what. Let me just change the name. Still bringing an error. Okay, it has cleared out. We shall fix it slowly by slowly. You see this program? This program has a method called pup age, and under it they are declaring one variable called age, and then they are initializing it to 0, which is okay. Then they are going on to they go on to update it by saying age equals age plus 7. Meaning this person is telling the computer, now I remove the other 0. I don't want it. Put whatever is there. Let me just remove this, not to confuse you. It's trying to tell the computer that now remove the other 0 that was there and put 7, right? But let me tell you one thing, that even if this 0 was not there, even if someone had just said int age then with the termination, this one, the semicolon, we are calling it a terminator. And even if that equals 0 was not there, and you want to initialize this variable again with the 7, don't you say, I don't want you to see you saying int age equals 7. That is wrong. Why? You have already told the computer that this is an integer data type. Why are you saying it again? That will be wasting time. Don't say it again. Just say age equals 7. Meaning, don't repeat the data type of a variable when you have already specified it, unless maybe you are working with another variable, right? So, meaning when you are initializing a variable, make sure you don't repeat its data type twice. That is wrong. So you can't say int age equals 7, yet you already said int age. This is what I mean. If it was like this, meaning you have created your variable int age, yes, which is okay. You have done what we call declaring a variable on line 7. So on line 5, then you on line 6, I see you are trying to initialize it with 7. You are trying to initialize it with 7. Let me first clear out this error. And you don't need to understand what I'm doing right now. We are going to understand a short time to come. As of now, that information is not important to you. Yes, it's not important. So we are saying you have declared and initialized in these lines. And this why is this one? Why are we saying this one is a local variable? It is local to the method pup age. Not any other method can access it. It is accessible directly in that method. It's only in that method where you can initialize it, and it's only under that method that you can print it. Are we together? You cannot come and print it outside this method. Yes? Sorry, this I have understood why I had an error here. Okay, but that one is not important as of now. So we are saying you can only print it within this method because it is local to that method. It is local. Like we Ugandans, we are local to Uganda. We are found within Uganda. That's why we say our local channels. Why? Because they are within Uganda, in our locality. Local channels, 10 TV, UBC, and so on, and what? The Sanyuka and so on. Because they are local, they are within our locality, within Uganda. Those that we access but outside Uganda are the ones we call international channels. So the same thing here. This age is written within the method pup age. Why are we saying within? Because you see that someone opens on line 4 and closes on line 8, and within the body, this one is what we call the body. Within that body, we see that it is creating the variable and is initializing it, meaning it is within that method. That's why we say that a local variable is a variable declared and declared within the main. So within a method, it's declared within a method. Here, it's declared within a method. This is what they mean. You see, it's declared within a method. So you don't need to cram these definitions. You can just remember them as you practice. So let's look at what you see. They're saying instance method. So instance variable declared inside a class but outside a method. How do we do that? How do we create our instance method? So our instance variable. This is our class fdemo. We are opening it on line 2 and closing it on line 16. So if you want to create an instance variable, you just come just below, or just under the brackets of the public class demo, but not under the method, not even under the main method, but just under the what? The public class, under the public class fdemo. And we are saying maybe you can do it on line 3, or just even after line 3. You can even do it on line 16, or in the middle here, but not inside any method, right? And then you can say maybe int local. That I've chosen my variable name to be local, which is okay. You can choose any variable name. Then you terminate. So this sorry. Let me choose instance, because I want to bring out what I'm trying to explain. Instance. So my variable is instance. Why? It is written, it's an instance variable because it is written under a class but outside a method. You see, it is not in any method. It's just under the body of the class but outside the method, right? And it can only be accessed using an object. We shall understand objects in a short time to come. So don't worry as of now. Don't worry so much. This one was wrong. Okay, what I've done is just trying to fix the errors, but that one is not so important. Don't worry about that. Okay. Sorry for those sorry for those that had not seen. You know, I talk so much and I'm usually so loud and it becomes hard to hear you popping in to join, but it's okay. We are still together. I've not left you so much, and I am sure for those who have just joined, you understand what we have been talking about, and it's not so much that we have covered, so you don't worry, you have not missed much. We were just looking at the different variables and their types of variables, and how can they, to what range can they be accessed. So you see this method, this variable we have created, we have called it an instance variable, because this, we are looking at different types of variables. Those ones you see there on the screen. We said we have local variables, instance variables, and then static variables. And then we went on to define the different types of variables. And then now we what you see down here, the brief definitions that we are looking at. And here we are trying to emphasize them, or to look at them in the concept of coding. So we are saying this one is instance because it is written under a class but outside a method. And the only way to access this one, you have to create an object for the class to access it. For example, you see here on line 14, I have created an object called the test. As of now, don't worry. How have you done that? That one is not important. But just know that I've created an object on line 14. And if I want to access the variable which I have called the instance variable, maybe I want to assign it a value, or I want to print it, or I want to do some additions on it or calculations on it, I will have to first use this object called test, right? Yeah, that's what we mean. So that's what is special about an instance variable. It is only created under a class but outside a method, but can only be accessed using an object, as you are seeing here. And if you feel like you have missed out anything on definitions, I recommended this link which I've shared in the group. We are using it for revision purposes. If you want to revise anything, it is very good. So the last thing that we looked at was the static keyword, so the static variable, which we said that it is declared under a class still, but using the static method, static keyword, meaning it is also accessed directly, but you have to use the static keyword when you are creating it. For example, let's do it here. If you want to create a static variable, you will say static. You will say static first, right? Static. Then you provide the data type, maybe integer. Okay, let me use float because I assume we all have integers. Static float. Then now you give it a name, maybe. We are working with static variable. So you say static, maybe that's my name. I'm just choosing a variable name. My variable name to be static val, static val. Then I terminate. So what I've done is that I've created a variable called static val, and this variable is static because it starts with the keyword static. It's declared with the keyword static. And what is the importance of this keyword static? It means that what if I create an instance variable and I don't want to use an object to access it? That's when you use the static keyword when you are creating it. Are you saying that it is also an instance variable? Why? It's also written under a class, but outside a method. And we said for such variables we have to use the objects. But what if I don't want to use an object? That's when I use the keyword static when creating our instance variable. Meaning here I can directly just say print static val down here in the main method, and it runs very well. Which is not the case with this one, which doesn't have static on it. Hope that one is also clear. So we are done with that. We are done with variables, understanding what variables are. So today, because we want to cover something very important, today my idea was that we cover something on structures. But I couldn't continue when I've not given you that basic understanding of Java, and that basic theory, and at least the build up of what we are talking about. But that doesn't mean that we are not going to look at structures. We have to look at structures. so that we shall know that we are progressing. Because I'm sure the test is going to move up to structures, even it goes beyond structures to look at classes and methods, because the lecturer looked at them. And she's the one going to say, not Xavier. And the her or the she knows that what we have covered. So she will have to look into it. So let's look at structures. And structures, when I say let's look at structures, I mean the control structures. Control structures. Yes, still under that link, we are moving to control structures. Where are they? Control structures. I think they're on top. Yes, control structures. Where have they hidden? They are here. Sorry, it's just passing by. You see, these ones in green. This is the topic we are going to look at, control structures, right now, and we are going to start with the decision-making structures. Just like it sounds, decision-making structures. I'm loading them. So in Java, we have to make a decision to achieve something. I hope now the screen is clear. Don't focus on the ads. Don't focus on the adverts. Focus on the content we are covering. So, what is the decision making? Like, when we talk about decision making control structures, these are the structures that are going to help us to do something after a certain condition has to be evaluated to be true or false, right? So in your program, if you feel like something has to be done or has to happen after a certain condition has been evaluated to be true or false, there you will have to incorporate the decision making control structures. Hope we are clear on that. So what you see here on the screen, I'm sharing what we call it a flow chart. We have seen flow charts, we have seen algorithms, and sometimes the flow charts are called pseudocodes. Those are called designing tools. That's why I told you to go back and read the theory. The Khaled is going to set that theory. What is an algorithm? Give an example of an algorithm. Or write an algorithm of a program to add two numbers. There, what she is trying to tell you is that write a step-by-step process showing how you can add two numbers in Java. And then she can attach their 4 marks and you lose out. The casting is just something. In other words, if I'm sorry, I sometimes talk about things that I feel like I have to talk about to emphasize them because they are important. Like, for example, when we talk about an algorithm, what is an algorithm? An algorithm is a step-by-step process followed in achieving a certain task. You want to add two numbers in programming, you have to know the steps you have to follow. For example, we know that we have to create two variables to store the two numbers we want to add. That's the first step. Then we will read the two numbers, maybe from the keyboard or directly from the program. Then after that, we need to carry out the operation of adding using the plus sign. That is step 3. Then step 4 is that we have to print. After printing, we stop. But the other thing that I didn't talk about is the start. Whenever you're starting any algorithm or whenever you're writing any algorithm, the first step is to start. If you don't start with the start, you have not started and the whole algorithm qualifies to be wrong. So always your first step will be start. That is the first step on any algorithm. Then stop. That's the last step. So every algorithm you will ever write, we expect you to have a start and a stopping point. So that was just a by the way. You go back and read a little bit on algorithms and understand them better. So this is a flowchart. A flowchart is also a graphical algorithm. So it's also an algorithm but in a graphical form. So this is a flowchart to show you how conditional decision-making structures look like. And here we see that this is here you have what you are trying to do, and maybe when the program here they are trying to show you that the program starts from somewhere. It's starting from somewhere. That's what discuss arco means. And you have to be knowing what each symbol does. what does this symbol do, what does this symbol mean. That I think you remember in C++ that question came in the paper. And if you had not, and I'm sure before the paper came, I had talked about those things, and people took them for granted. And when they came, you saw someone could tell you, explain the 6 different symbols we use in algorithm, also in flowcharts, and their meaning. I think that one came and it carried something like 12 marks, whatever, 6 marks. And all you had to do is to draw this symbol, and you said it's the condition symbol. It is used to show this, to do this and this and that. So take your time, go and look at this link. It has a detailed explanation of all this, clear explanation. So here we are saying that this one tries to show that the program starts from somewhere, and as it tries to execute, it encounters what? A condition. This is a symbol for a condition. When a condition is encountered, we expect it to out 2 results. The condition is either true or false. So what you see here is what we have called the conditional code. Like what should happen if the condition is true? That's what we call the conditional code. Then if the condition is false, what should happen? That's what we have called the if condition. If that's what you see this side. That if the condition is true, then do this, continue downwards. Otherwise, if it is false, move to the right like that. So then we come to a stop. So we have different decision making structures as you see them on the screen. We have the if statement, the if else statement, the nested if, and the switch. And as of now, before this session ends, I want to guarantee you that you're going to understand these 4 here. So we are going to just look at the decision making structures today, and if we by the next session, if we meet again, we shall move to the loop control structures. But as of today, we are going to focus on these 4 here. Let's start with the first one. That's the if statement. We are going to understand it theoretically. We code it, we move on. Understand code, we move. Understand code, we move. So the Java if statement, like it sounds if. The if follows this syntax here, you see. It consists of a Boolean expression. You know what a Boolean expression is? An expression is like a calculation, or is like A equals B. Let's see it. If you are saying A is greater than B, that is an expression, and we are calling it a Boolean expression because it can either be true that A is greater than B, and it can also be false that A in no sense is not greater than B. So any expression that is going to return a true or a false value that can be true or false, we call it a Boolean expression. So we are saying a Java if statement consists of a Boolean expression followed by one or more statements. What does that mean? This is the syntax. What you see here is the general syntax for a Boolean an if statement. That you write if, inside here you provide what we call, these people are calling it a Boolean expression, but me I call it a condition. Me I'm going to call it a what? A condition. I'm going to call it a condition. So inside here I provide your condition. Here I'm trying to show you how generally we write an if statement. That you say if, then inside here you provide your what? Your condition in these brackets. You open these brackets. Then inside them you provide your what? Your condition. Then from there you open and close. So this one will be the body for your if phrase, for your if structure. Then inside here they are trying to tell you that there will be many statements, or one or nothing, like whatever you want to do after this condition is true. Whatever you want to do, whatever you want to be done when this condition is true, you write it inside these brackets, this body here. So let's try to understand it in the program, the software, or in the compiler. Let's try to understand it in the program with an example of a program. So let me remove all this because as of now we don't need it. We're just using it for explanation, and I'm removing it, just modifying my program. So that I just want to remain with the general syntax. So I'm going to explain to show an example to show us how the if condition works. So if we want to check which number, or if we want to check to print which number is greater than which one, like if you have two numbers and you want to print which one is greater. For example, if we have two numbers A and B, so we have to first create a variable to store it. So okay, we are writing a program that is going to check which number is bigger than, okay, which number is bigger, that's all. It's going to check two numbers and print which one is bigger. So, meaning we shall have, what do we need? This is also a trick that if they tell you to write a program, first analyze the question, know which things you want to store in your program, like which variables you will need, how many variables you will need, that is the first thing, which conditions you will have to look at. Then you first write down your plan on how you are going to attempt the question. For example, our question here is that we want to write a program that is capable to tell the user that A, are not even necessarily telling us that A is greater than B, but telling us maybe if A has 9 in it, you will say B and B has 7, you'll be able to say 9 is greater than 7. That means you need two variables. Store the first number and the second number. Then you need a conditional structure which we have called the if now to do that. So we shall say, maybe these numbers, you have to know the data type. Are you going to use floating data type or integer data type? So as of now, we are going to use integer. So we shall say int A. Then the other thing you need to know, will these numbers be entered from the keyboard by the user, or I'm the one going to specify them as the programmer? And as of now, I don't want to confuse people by entering things from the keyboard. That is another step. Right now, let's just write a simple program that is just going to check the two numbers. You are going to enter them as programmers by saying A equals maybe 5. And that means I've declared and initialized A with the 5. Then comma B equals 7. Then I terminate. Every statement you write in Java, you have to terminate it. And what do I mean when I say statement? This is not a statement. Line 4 is not a statement. Why? Because it is a block. It has its own block. It has where you are opening it and closing it. So I don't expect people to terminate here. When you terminate, you see the error comes. I think you can see that red lining. So we don't terminate blocks. We don't terminate blocks. Like you cannot terminate a class. You cannot terminate it. You can also terminate a method, but at a certain point, as we shall see when we come to program further. But right now, just know that this is a statement because it's just telling you that int A equals 5, B equals 6. You are just declaring and initializing the variables. Now, how are we going to check if A is greater than B using a program? We shall say if, then you, without a space, please, without a space, you open and close those brackets. Then, before you have even written your condition inside, open the if and close it. You see, I've written if, open these brackets here, in which I'm going to write my condition. Let me magnify a little. Here, I'm going to write my condition inside there. But before even doing that, because here I'm using a software, but when you are using a pen, you will have to first write the condition inside. So here I'm going to write my condition. Let me just write something like condition. Inside there, I'm going to write the condition. Yes, like we have said. Then after, here I will write whatever I want to be done inside these brackets, these ones. So this one is the body of my if condition, my if structure. So inside here, I will be writing whatever I want to be done after this condition is true. So we want to check which number is greater than which one. That means the condition is being greater. So we will say if, then inside we say maybe A greater than B. So I have provided my condition. So the condition is A being greater than B. If this condition is true, what should be done? I want to tell the user that A is greater than B, only if this condition is true. If it's not true, that means I want to tell the user that B is greater than A, right? So, how do I do that? I write the statement to tell the user that A is greater than B, so I will say system.out.println. Hey, for those who don't know, that statement I have written just right now, let me even complete it and terminate. Line 9, which I have just written, is the one that we use when we want to display something on the screen. And I'm not going to talk much about it because I assume people have been at least attending the lecture, and that is best can they understand. For those who have not been attending, it is okay. It is okay. You go and use that link I've given you. Just read the theory. The theory will give you a brief understanding. But just know that this line I've written here is the one we use when we want to print something on the screen. And whatever you want to print on the screen, you write it within these brackets. These ones here. These ones. Whatever you want to print, you write it inside there. So inside there, we want to print a statement saying A is greater than B. A is greater than B. So I will say A. But remember, A is a variable. But the media print it as I'll even explain that point. But let's say A is greater than B. Someone will ask, why are you putting it in double quotes? For those who have not been attending the lectures, we want to tell you that when you are printing something as just a normal sentence, when you are printing a sentence falls under a character, a data type we call string data type. And whenever you are working with the string data type, okay, we have a data type called the string. I'm sorry I didn't look at data types, but I assume at least people have a small knowledge on them. But whenever you want to look at a string as a data type, okay, whenever I want to display something, which is now a sentence like A is greater than B, it's a collection of different characters. What is a character then? Okay, anything you see on your keyboard, when you look at your keyboard of the PC or the phone, anything you see there is a character, and a collection of those things is what we call a string. And whenever I want to print a string on the screen, you have to put it in double quotes. As of now, just get to know that. And if you want further explanation, I beg you either come to my inbox, we talk further about it, or you go to that link which I've shared in our platform, and you try to read further. Because as of now, we can't go back to that side, but it's okay, we can continue. So we want to print A is greater than B after or only if the condition on line 7, which we have put inside our if, is really true. So what do you expect out of this program? If we are to compile it and run it, we will see that our condition is true by looking at it as humans. We see that A is greater than B. So meaning, what should we expect? We expect to see our program executing A is greater than B. Let's run and see. Yes, this is where we run it from, for those with the software. For those with the software and you don't know how to use it, you have to use this button you see here to run your program. And the program runs, but nothing gets displayed. Why? Meaning our statement has not been executed. You look, this one. Meaning our condition is not true. You see, A is not greater than B. A is 5 and B is 7. What does that mean? That when the condition failed to pass, the condition is not true. A is not greater than B. That means the whole of this becomes nonsense. It becomes useless. They don't even look at it. But if in any way we modify our A now to become 9, and we run our program again, let's run again. We see they are telling us that A is greater than B. Are you seeing this output? These others ones, don't focus on them. They're just compiler, system words. Don't focus on them. Where you see process returned, that one is not important. They're just telling us the time the program has taken to execute. We don't need it. But you look at what I've highlighted with yellow. They are trying to tell us that A is better than B. Why? It's not because it is true that the program, the computer did not necessarily understand that A is better than B, but it checked the condition. The condition was true that A is better than B because A is 9 and B is 7. And because the condition is true, they went on to execute whatever is under that brackets of the if statement. Hope that one is clear. So, unless this condition is true, whatever is here will be executed. But if it's not true, this will not be executed. Hope we are clear on that. I'm going to modify a little bit. What if I don't want to see this? Like, if I run the program, I don't want to see A is better than B. I want to see what is in A and what is in B. Like, I want to see 9 is better than 7. Like, I don't know if I'm a little bit clear. But, like, I want to see that when I run my program, I don't want to see A is better than B. Instead of where I'm seeing A, I want to see the value that is better than B. The real values, I want to see 9 and I want to see 7. How do I achieve that? Here I'm trying to teach you how we use the print statement, the system out that printed in line 7. I'm trying to emphasize how you can use it interchangeably. So I don't come and say, me I already know what is in A. Let me write here 9 is better than what? Better than 7. Yes, when I run the program, it will say 9 is better than 7. But that's not how I want you to do it. Because this is wrong. It is right in a way that it does what you really want to do. But I don't want you to, I want you to assume you don't know that the value in A was 9 and the value in B was 7. How do you achieve that? Let me remove all this first. So how do we do that? This is how we do that. You come and look at, okay, I want you to use only, like in your print statements, I want you to use 9, A and B, not 9 and 7, but and the output, I want to see 9 and 7, not B and A. How do I do that? That one, I will need to say system.out.println, then inside there I will write A, easy, but because A is not a string, or it's not just a normal character that I'm just printing. It's a variable that we created. I think you can see it on line 6. It's a variable that we created. So for it, I can just write it without putting it in a character. So in a quotes, maybe double quotes or single quotes. And then if I say easy, when you look at easy, it just brings the error. An error. Why? Because easy is not anywhere in our program as a variable. But it is just a string. It's just a collection of characters. And we said, when you want to print a collection of characters, it has to be in double quotes. So meaning I have to put it in double quotes like this. Easy. Are you seeing? Like that. But still it brings errors. Why? Because however much you are printing it in double quotes, but there is no difference. They are not trying to separate the variables from the string. How do we do that? Whenever I want to print two different concepts using the same statements, you will need to use the plus operator. This one. That one you see on the screen. This one. You have to use it when you want to print something different. Like, it's called the concatenation operator. Why? To concatenate means to add some things, not adding the mathematics we know. Like, for example, if I have a name, if I have two names, 10, and the other name is also 10. But I want it, okay, these two words, 10 and then 10. But I want to make it 1 to become 10, 10. There I will use this plus. This plus in programming will not necessarily now mean, because it can be used for two concepts. It can be used for adding, it can also be used to concatenate. Adding, we all know what adding is, adding two numbers, or three or any. But concatenation means you are getting two different things and you are bringing them close or intact with each other. That's what we are calling concatenation. So if you want to concatenate 10 to 10 to make 10 10, that's the plus sign. That's what the plus sign will do. So we have two strings, 10 and then 10. And then we are saying when you put them in double quotes like this, so if you put them in double quotes like this, and then you put a plus between them, you are trying to tell the computer that please, when you come to printing these two strings, add them so that the output will look like this. The output will be 10, 10, 10. So this one here, you are trying to concatenate, you are trying to add up two different things, not adding the mathematics, but trying to merge them together. 10 to bring 10 10 in one thing. So let's go back to the printing. So we have two different things here. We have a variable and we have a string. So the only way we want to, when we want them to be in one sentence, but there are two different concepts, that's then when we have to use the plus symbol. Are you seeing? The error even disappears. Here I have written the variable, and we are saying for a variable, because it's already defined in our program as a variable, we don't need to put it in double quotes. We just have to print to print it, or to say it out, to state it. Then we put a plus, because we want to print a string is greater than what? You see the spaces I'm creating? Those spaces are necessary because we want to have some space between A and is. So A plus, why is the plus important? That when we run our program, we want to see A as a variable. And when I run this program, let's first finish writing the entire code. Okay, we have written A plus, then in string, in string is greater than, because that's just a statement. That's just a string, a collection of characters. It is not in our program anywhere as a variable. Greater than what? A is greater than B, but B is also a variable in our program. And because it is a variable in our program, you see it on line 6. For it, we won't need to put it in a double quotes. So we just say B. I think you can see when I even typed B, it brought a box there to show that it is a memory location. Some compilers are so good that they can even show you something. So when I put B there, shows that this is the memory location. But why is it bringing an error? Because we are saying, let me create a space. Someone can say, maybe you have not created the space. I've created it, but still the error happens. Because we are printing a variable, and then there is a string in front of it. They are not separate. They are separated with the space, but they are not the same. So if we want to join them to be printed on the same line or to be printed together, we need to bring something to concatenate them or to merge them together, which we call the concatenation operator, which is our plus symbol. So I will say plus in front of B. See, the error disappears. So what does that line 9 do? Line 9 is going to print a statement saying A is greater than B. But this time we shall not be seeing A. Rather, we shall be seeing a value in the variable A and B. Because we said the A and B are variables, and we said the variables are named memory locations. Meaning they are not, the value in it. Okay, there are locations that contain some data in them. So when we say if we are printing A as a variable, we are printing it, we are just printing what is in that memory, not the memory name. Hope we are clear. So meaning when we run this program, we are going to see something different. When I run this program, most of you will expect to see A is greater than B. No. We shall see 9 is greater than 7. Let's run and see. Let's prove that. You see, I've not written anywhere, not anywhere in my program have I written 7 or 9. Are you seeing it there? It's not there. But when I run the program, I only see 9 and 7 is greater than 9 is greater than 7. Yet I have not written anywhere 7 in my output statement. I have not written anywhere 9 in my output statement. What have I done? I have just put there the locations storing those variables, those values. I have just put there the memory locations or the variables. And then these variables, again I think you can see that A comes here, A is here, 9. A, you see A? It's the one storing 9. It is in the same position. B is here, it is also here as 7. Meaning, you don't expect to see 7 coming in the place of 9. Yeah? Unless maybe when you have interchanged the positions of your location variables, right? So hope you have understood how that is achieved. I was trying to explain two things at the same time: the input, the output statements. When I was trying to scroll through the screenshots, I skipped some things because I told you I will explain them when we are coding. The output and input objects, they are important, and they are the ones I'm trying to explain right now. Like, I will not go back and try to explain to you the system.out.println because I have done so in the coding. Now, what if I have some other things that are displaying down here? Okay, like the condition, when it is true, under it you can have many other things that can execute after the condition is true. Not only printing or what, but that was just an example, right? Okay, let's move to the next structure. The next structure. Are you seeing that we only do? Okay, the output only happens only if the condition is true. But what if you want to do something even if the condition is not true? Like, let me give an example. Like, if here we are focusing on saying, that A is greater than B. But what if the condition is not true and we want to say that B is greater than A? Sorry, Mr. Dema, you can unmute and ask.
Mr. Kawes, I would like to inquire whether in Java
but you
you
can
have
ask,
this same program.
You can ask
Whether you have this same program that will prompt the user to choose two numbers, let's say 7 and 9, where you have mentioned, and then it prompts the user to insert from the keyboard, let's assume,
okay.
and then decides by itself internally, say 9 is 7 greater than 7.
Okay.
Do you have that option?
Yes, we can also have that situation. Thank you.
Okay.
Why I didn't want it to allow to work with an example where the user enters from the keyboard is because it may look complex. Some people have not seen how do we enter from the keyboard, but we can write that program shortly, and then maybe we close the session. That means I will have to first pause a little bit on the control structures and first focus on finishing the point of entering from the keyboard. Then maybe when we come back, we shall just continue from the control structures. Because we want to look at the input statements and the output statements at the same time, and we close that deal, right? Hope let's do that. What Mr. Dem has requested. We enter from the keyboard, we output, we only look at maybe one, like we have looked at that at the if statement. Let's use the input statement. Let's understand the input statements, and then we call it a night. We call it a night. Okay. Let's dive into how to input from the keyboard, like how to get data from the keyboard and we feed it into our program. To achieve that, we have different classes that we use in Java. What you are seeing me sharing are the input and output objects, or we call them input and output streams. On our course outline, we have what we call streams. And we have 3 streams in Java. We have the system.in, system.out, system.error. Someone can tell you to explain what each stream does. Those are streams. The system.in reads data from the keyboard. System.out displays data on the screen. I think you have seen us using it. System.error displays the error message. Then the other thing we need to know, that these streams, they are defined under specific packages and libraries. In Java, we have what we call a Java library that has different packages, and then the packages contain different classes. So the Java library has a package called Lang, the Lang package. This one, L-A-N-G, Lang package. In full form, it's the language package, Java language package. So the Java language package, or the Lang package, when you want to use any of these streams, you have seen the 3 streams up, you have to first import it by saying import java.lang.star, what you are seeing here. But you have seen in many of the programs we have written, however much we are using system.out, we have not written anywhere this statement. Why? Because by default, Java will always, any program you write will always write this statement. Like it will be executed by default. You don't need to write it in your programs. Even if you write it, it is okay. But it will be ambiguity. You'll be just repeating something that the system can do for you automatically. So we have the input and output streams. And we have seen, at least we are familiar with the system.out.print. So this one, we can use it when you want to print everything in a single line. System.out.print. Like we can say system.out.print welcome. That one is used when you want to print something on the keyboard. This system.outside on the screen. System.out.print. Then inside here, you write whatever you want to print. For example, this person wanted to print welcome. Then system.out.print. Then inside he wrote Java. When I run a program with these 2 statements, what do you expect will be my output? Those are the things that you need to be knowing, because someone will just write a program, then tells you to write the output. You write an output which is just similar, but not this, which is just resembling, but not necessarily the same output. You'll be wasting time. For example, let's write the program. Let's just modify this program. We say system.out.print. Then inside we are saying we are terminating. So you write your statement like that. System.out.print. Then inside here you specify what you want to print. For example, I want to print welcome. Welcome to. Then I write the same line again. Control C. I'm just going to paste it. Control V. Inside here I'm going to say Rich K Technologies. To our online sessions. Our online sessions. Our online sessions. So I'm trying to do this for those who have not been attending the lectures, so that you can understand where we are. We can be at the same pace. Most of you are familiar with the print ln. Now when you reach in the paper and they have written for you print, you'll think it is wrong. It is not wrong. It's also correct. Let me first terminate out this line. What I've done on line 7, I've just commented it out. Commenting out a line of a code is like when you are writing your paper, your answers on the paper, and you cross out a certain line. So I've just crossed it out, meaning the computer is not going to consider it. It's going to ignore it. So when I run this program, the output is welcome to this one. These ones I told you the last 2 statements, don't focus on them. They are system program. Just system output. Welcome to is my output, and that one is okay. So meaning system.out.print, then inside here you write your statements that you want to print, is used when you want to print something but on one line. Again, if you want to print something else, like I'm now making the computer to understand that this line is now useful by removing the comments. When I run again, you see they are telling us that welcome to our online sessions. Let me first take a little space here. When I run, there are two print statements, but there are two statements. Welcome to our online sessions. Welcome to our online sessions. You see everything is in one line. However much I've used the two statements. What does that mean? That print is only used when you want to print everything on one line. But when you want to print things like our welcome to our online sessions on a new line, like if you want to achieve something like this one, welcome Java, like when you want to bring the next statement, our online sessions on a new line, there we shall use println, system.out.println. I have seen most of the students 90%, if not 50%. Instead of arrow, you write n. That is a different thing. This is not printing, it's print ln, not in. And why is it ln? Because we are printing line, print line. So I will just come and I put ln. I've just modified it a little bit. When I run again, I think now you can see some difference. Welcome to our online sessions. Welcome to is on a new line, and then our online sessions is also on a new line. So that's how the system.out.println works. It is used when you want to print statements on two different lines, right? So that one is clear. We are not going to take a lot of time on print statement. Our focus is going to be on the input state side. That's the one that confuses most. So when we want to get something from the keyboard into the program, there we will need to use specific key terms. And I would like to apologize in advance that we were supposed to run from 8 to 4, but because of our coverage and because of because I want us to finish up on something, I would like to borrow 15 more of your minutes after 10, like we may end at 10:15, because I want us to finish input and output streams, like how do we display something on the screen, then how do we get something into our program from the user. Then maybe we shall call it a day. Next time we come back, we shall look at control structures. Then from control structures, that's the loop control structures. Then decision making control structures. There we shall dive into the classes and methods, objects. Then now there we shall be on the real coding. Even here we are now on real coding, but we are still on the basics. Yeah. So when you want to get something from the keyboard, or you want a user to enter information from the keyboard into our program, we use a class which is also system defined, which is already in our Java package or our Java library. That class is called the scanner. You see, Java is English because you are getting something from the keyboard. Of course, it's like you are scanning something and you are feeding it into a program. So there we shall use two classes. We have the scanner class and the buffered reader class. And I want to tell you that the buffered reader class is also important, but as of now we are not going to look at it because the lecturers have not yet taught it and I don't know if they will teach it. So don't focus on it. Focus on the scanner class. because the buffered reader class is used when you want to read something from a file or from a keyboard. Like if you want to get information from a PDF, and you feed it into your program, there you will use the buffered reader class. But that one, let's not focus on it here, because I don't know whether the coverage of the lecturers will reach there or it won't reach there. So as of now, what they have covered is the scanner class, and that's what I'm going to focus on. So the scanner class, we have said it's a class under the Java library, but under which package? The utility package. In Java we call it the util package. So meaning if you want to use the scanner class, you have to first import the library in which it is. Then you import it also. Are we together? So whenever you want to use a class that is defined within the system, in other words, that is a system class, a class that defined in our system, you have to first import it using the import keyword. The import is a keyword that we use in Java to import libraries, to import packages and classes from the Java library. So we are saying it is in the utility package class. Then the buffered reader is in the IO, input output, but that one don't focus on it. We are focusing on the scanner class. So this is the scanner class. It's the one that we use when you want to get things from the keyboard. So the input. let me explain the scanner class very well, and here I'm going to explain it in a way that is more detailed manner. So under a class we can have methods. Under a class we can have methods. We talked about encapsulation, and we get different methods and variables and we store them and we bind them under a single entity, and we saw an example of students, and the students can have methods and variables in it. So the same thing here. Under the scanner class we have different methods, which is and these methods are outlined here. I think you can see them. We have next int, next float, next double. These methods they are under our system defined class, which we have called the scanner class, meaning they are also system defined methods, meaning they are also keywords. Okay. So let's understand that under this scanner class we have a stream which we call the system.in, which is helping us to read things from the keyboard. And then we see that it has the different methods, and these methods are also instance methods. Why are they instance methods? What did we talk about when we were talking about variables, which are instance variables? We said instance variables are methods, are variables written under a class but outside the method. So the same thing, when I say an instance method, I mean this is a method written under a class. And we said what was so special about instance variables, we only access them using objects, meaning you have to create an object for a class, right? And then you can access it. So the same thing for the instance method. If you want to access and to use an instance method, you have to create an object for the class, then you access that method, right? So what I'm saying is that all these methods you see here, they are under a class called the scanner, and they are instance methods, meaning to access them or to use them, you have to create an object, right? For under the scanner, you have to create an object for the scanner class, and then you can access them using object name dot then the method you want to access. So for example here we see that you can create an object called the SC for the scanner class, and then you use this object SC to access these methods by saying sc.next, sc.next int, sc.next float, sc.next double. This SC you see here, it's just an object that someone created. You can choose any object name that someone created for the scanner class, and is using this object to call these methods or to access these methods under the scanner class. So what you see here, sc.next, sc.next int, sc.next float, sc.next double. Someone is trying to access these methods under the class, but using the object sc. Hope we are clear there. If you have any question, you can first unmute and ask. If we are good to go, you can continue. Yes, let me continue. Yes, anything? Nothing, eh? Okay. So, because we had not reached the level of creating, objects, we had not reached the level of what? Of creating objects, and we are saying that to use the scanner class, we need to create an object. That means that will be too much to take in, not so? Yes, someone unmute and tell me, don't you think it is too much to take in if I continue with this concept? Yes, someone unmute and tell us, should we continue or we call it a day? We shall start from there, because I think people might be tired, given the fact that it's a weekend and programming can be too much for you to take in if we continue. Mr. Dema or Mr. Ruhweza?
It's okay. Let's first watch the Man City match.
Okay.
Then we catch up next time.
Okay.
I know 10-10 is waiting for that match.
Exactly. Okay, so thank you for attending today's session. I think it has been a little bit boring because less of programming has been in it. Most of it we have been building on the initial concepts. But when we meet again, we shall just finalize on the input, on how to input from the keyboard. Then we move into the control structures. But I advise that as you be there, please use this link very well. Use it as much as you can that I've shared on the platform. It has good notes, good information, very brief and with good explanation. Go and understand the theory. And as you prepare for the paper, go and read those notes that the lecturer sent for the theory that contains the system design, implementation, testing, and so on, so that you don't be caught outside the box. Otherwise, I would wish to say good night and try to remind you, for those who have attended last time and you didn't clear out on with the treasurer or with the account, please do so, because we are running out on an account, yet we need to buy data and other things. So just to keep you reminded, make your deposit as soon as possible, so that next time we shall have data to access the online services. Thank you. Blessed night. Unless you have anything, that's all from me. I would like to log out if there is anything. I would like to log out. If there is anything to ask, you can ask now. Otherwise, it's time. Ate tulikodinze session niyo nasonga era tebaddemu bulungi. Agirekodinze?
It is still on recording.